Hello everyone, welcome to the last live session for the course Structure, Form and Architecture, the Synergy. This is an NPTEL course and the course instructor for this course is Professor Shubhajit Sadhu Khan, and he's a professor at IIT Roorkee right now. I am Shreya Shukla. I am currently doing my PhD from IIT Roorkee and I am the NPTEL TA for this course where I solve previous year questions where I tell the solutions of previous year questions to help the learners solve this year's assignments. So this is today we will be doing week 8 assignment 8 and this is the last live session for this course. We will wait for 5-10 minutes for others to join and then we will start with the session. So we will start with the live session. Um, so the course is called Structure, Form and Architecture, the Synergy. And the terms that are used in this course, the four terms in the title of the course are structure, form, architecture and synergy. So what do all these terms mean? Structure means, structure may mean a lot of things in different contexts, but in terms of architecture, it refers to the system which is used to support and transmit possible loads of the building to the ground. Structure gives stability and it also resists stresses and strains. What is form? Similar to structure, form also can have multiple meanings in different contexts, but in terms of architecture, a form is a three-dimensional object or building that is perceived by a viewer in space and time, and it is made possible for perception by the action of light and shadow. What is architecture? Architecture is the art and building, art and technique of designing and building. And what is synergy? Synergy basically means the interaction or cooperation of two or more organizations, substances, or agents to produce a combined effect which is greater than the sum of their separate effects. Which basically means that if we added the effects of three entities separately, uh, that would give so when we talk about synergy, the amalgamation or the interaction or cooperation of more than two agents together, the the output is bigger than the combined effect of their separate sums. This is what synergy means. So synergy is not just summation of their effects, but it's bigger than that, because the output is the amalgamation of all the entities, which makes it more complex and with a bigger effect. So the course covered in the last week of this NPTEL course, the syllabus for the last week, week 8, there were 5 lectures, and the lectures that were covered were evolution of high-rise structural system, which covered what high-rises were in the past and what it means right now, the evolution of high-rise system, right from the first skyscraper building in Chicago, and then the uh, subsequent increase in the high-rise buildings, skyscrapers, the terminologies, and then 2 parts on the structural components, where different kinds of structural components that are applicable in high-rise structures has been discussed in great length. Then 4th lecture was about mega structures and architecture case studies, in which uh, the most famous architecture case studies of mega structures was discussed, like the Burj Khalifa and others. Then the last lecture of the entire course was about the architecture and structure of the past, present and future, where a brief journey through the past structures, what is happening contemporarily, and what would be the future was discussed in this lecture. And the future was not talked about just in terms of technology, but also in terms of sustainability, because people are becoming more sensitive and understanding of the environment currently. So without any further ado, we will start with the session. So question number 1, I would be doing 15 questions today. So we will start with the questions. The first question is, in the system where the major part of the lateral load resisting system is located within the interior of the building is called. And the options are interior structure, exterior structure, hybrid structure or core structure. So the question is saying that a system, here the system means the structural system, in the system where the major part of the lateral load, as in lateral load resisting system, as in the lateral load resisting system, or the major chunk of the lateral load resisting system in a system. Lateral load resisting system is located within the interior of the building. What is that kind of system or structure called? So what is an interior structure? In interior structures, steel columns and beams are clustered at the core of the building's skeleton. The steel columns and beams provide the structural strength for the high-rise building. A system can be referred to as interior structure when the major part of the lateral load resisting system is located within the interior of the building. What is exterior structure? In this technique, steel columns and beams are at the perimeter of the high-rise buildings. They provide structural support and support the entire building by acting as a skeletal support. If the major part of the lateral load resisting system is located at the building perimeter, not parameter, perimeter, that system, structural system, is referred to as exterior structure. It should be noted that the interior structure is likely to have some minor components of the lateral load resisting system at the building perimeter, and the exterior structure may have some minor components within the interior of the building structure also. What is a hybrid structure? Hybrid building is simply a structure that incorporates more than one of the five commonly used structural elements in its construction. In most cases, hybrid buildings include structural steel as well as wooden supports and structural wooden beams, etc. What are core structures? The core of a building in its interior elements such as staircases, elevator shafts and pipes. You can consider the core of the building to be anything that connects the other spaces of the building or houses, building elements such as mechanical devices or wiring and pipes. So our answer is interior structure. In the system where the major part of the lateral load resisting system is located within the interior of the building is called an interior structure. Question number 2. Match the following buildings and their locations. So 3 buildings have been given and 3 locations have been given, and you have to match these buildings with their locations. So first is the buildings are Seagram Building, International Commerce Center, Kingdom Tower, and the locations are Hong Kong, USA and Saudi Arabia. So first we'll talk about Seagram Building. So Seagram Building is a skyscraper. I have added the image and the plan of the Seagram Building. Seagram Building is located in New York City, USA. It is designed by Ludwig Mies van der Rohe with minor assistance from Philip Johnson, Elie Jacques Kahn and Robert Allen Jacobs. The tower is 157 meter tall with 38 stories. It is an international style building with a public plaza and initially served as a headquarters of the Seagram Company, which is a Canadian distiller. It was completed in 1958 and it's office type. The type of the building typology is office and the architectural style is international style. Then International Commerce Center, ICC. It is a 108 story, 484 meters super tall skyscraper in West Kowloon, Hong Kong. It was the 4th tallest building in the world, 3rd in Asia, where its construction was completed in 2010. As of March 2023, it's the world's 13th tallest building by height, world's 10th tallest building by number of floors, and the tallest building in Hong Kong. The architects were Cohn Peterson Fox Associates, Belt Collins and Associates, Woong and Owang HK Limited. The structural engineer for this building was Arup, and the type is hotel, dining, offices, and observation deck. So I have also added the plan of the building and the view of the building. Then the 3rd building, Jeddah Tower, which was previously known as Kingdom Tower. It is a skyscraper construction project currently on hold. It is located in Jeddah, Saudi Arabia. It is planned to be the first 1 kilometer tall building and the centerpiece and first phase of development and tourist attraction known as Jeddah Economic City. In January 2018, building owner halted the structural concrete work with the tower about 1/3 completed due to labor problems. The design created by American architect Adrian Smith, who also designed the Burj Khalifa, incorporates many unique structural and aesthetic features in this building. The type is mixed use, office, hotel, residential, apartments, observation and retail. The architectural style is neo-futurism and the construction started in 2013 and it's currently on hold. So our answer is that Seagram is located in USA, so P2. International Commerce Center is located in Hong Kong, Q1, and Kingdom Tower is located in Saudi Arabia, R3. So the correct answer is C, P2, Q1, R3. Question number 3. Type A 101 is an appropriate example of diagrid structure, tube and tube structure, outrigger structure, super frame structure. So Taipei 101 is located in Jinyi, Taipei, Taiwan. The total height is 508 meter. The number of floors are 101. The area of the plan is 50 meter cross 50 meter. Cost of construction was 700 million. Architects were C.Y. Lee and partners. Structural engineer was Shaw Shie. It was started in 1998 and the building is an office complex plus mall. The structural system of the building include outrigger trusses, movement frames and belt trusses. So this is how there's one few sections of the Taipei Tower, the plan of Taipei Tower, and also the outrigger trusses that have been used in Taipei Tower. So looking at the plan of Taipei Tower, the central core has a shear frame system and the perimeter has mega columns or super columns. Then there are outrigger trusses on different floors, and there are belt trusses and there are radical trusses in this. The structural frame of this building was developed by adding outriggers to shear frame systems with core and to couple the core with perimeter columns. Outriggers are basically structural elements that connect the core to the perimeter columns at one or more levels. So outrigger trusses are basically added at different floors or different levels in which the core is connected to the outer columns. So we have mega columns in Taipei 101 on the surrounding, and we have a central shear frame system, and there are outrigger trusses on different floors which connect the core to the mega columns. So the answer would be outrigger structure because outrigger trusses are used in this structure. So the correct answer is C, outrigger structure. Question number 4. Which of the following high-rise structural system has the highest structural efficiency to build for, tall structures? Concrete framed tube, steel diagrid, tube and tube, steel framed tube. Which of the following high-rise structural systems has the highest structural efficiency to build tall structures? So framed tube system is one of the most widely used tube system. Compared to tube and tube system, it features a much more stiffer exterior tube in this type of system. The stiff tube is achieved through closely spaced columns connected by deep spandrel beams which are firmly joined together to make the stiff exterior shell. So what happens in framed tube is that the framed tube has a really tough exterior tube. It's a tube type of structure, but the exterior is really stiff, and that stiffness in the exterior is achieved by closely spaced columns connected by deep spandrel beams which are joined together to make the stiff exterior shell. Then tube and tube. The tube and tube system is also known as hull and core system, and it consists of a core tube inside the structure which holds the services such as utilities and lifts, as well as the usual tube system on the exterior which takes the majority of the gravity and lateral loads. Along with the exterior tube, a core is placed to resist part of the lateral load. So in tube system there are two tubes, one internal tube which hosts the services such as utilities and lift, and then we have one core also. And in framed tube there is no internal tube. There might be a core, but that core might not necessarily be structurally a part of the structural system. But in framed tube there is a stiffer perimeter or the outer structure. Then diagrid. A diagrid or a diagonal grid is a framework of diagonally intersecting metal, concrete or wooden beams that is usually used in the construction of buildings and roofs. It requires less structural steel than a conventional steel frame. The diagrid obviates the need for columns and can be used to make large column-free expanses of roofing. So the options were concrete framed tube and steel framed tube, and then steel diagrid and tube and tube. So the answer is highest structural efficiency is in steel diagram. Question number 5. Write in descending order the following tall buildings in terms of height. Empire State Building, Woolworth Building, Petronas Tower, Sears Tower. So this is how the four buildings that have been mentioned in the question look like. Empire State Building, Woolworth Building, Petronas Tower and the Sears Tower. And we have been asked what is the descending order the following tall buildings in terms of height. Descending order as in from tallest to shortest. So Empire State Building is 102 story Art Deco style skyscraper in Manhattan, New York. It was designed by Shreve, Lamb and Herman and built from 1930 to 1931. Its name is derived from Empire State, the nickname of the state of New York. The building has a roof height of 380 meter and stands a total of 443 meter tall, including its antenna. The Woolworths building is an early American skyscraper designed by architect Cass Gilbert, located at 233 Broadway in the Tribeca neighborhood of Manhattan in New York City. It was the tallest building in the world from 1913 to 1930 with a height of 241 meter. More than a century after its construction, it remains one of the 100 tallest buildings in the US. The architectural style is neo-Gothic. Excuse me. The Petronas Tower, also known as KLCC Twin Towers, are a pair of 88-story super tall skyscrapers in Kuala Lumpur, Malaysia, standing at 451.9 meters from 1998 to 2003. They were officially designated as the tallest buildings in the world until they were surpassed by the 204 completion of Taipei 101. The Petronas Towers are the world's tallest twin skyscrapers and remained the tallest buildings in Malaysia until 2019 when they were surpassed by the Exchange 106. Architectural style is postmodern Islamic architecture. The Willis Tower, originally known as Sears Tower, it's 110 story and 442 meter skyscraper in the Loop community area of Chicago in Chicago, Illinois, United States. It is designed by architect Bruce Graham and engineer Fazlur Rahman Khan of Skidmore, Owings and Merrill SOM. It opened in 1973 as the world's tallest building, a title that it held for nearly 25 years. It is the third tallest building in the Western Hemisphere as well as the 22nd third tallest in the world. Now, this is an image which shows the different skyscrapers along with their height. So we have the tallest structure right now at Burj Khalifa, 828 meter, Taipei 101 at 508, Petronas Towers at 452, Sears Towers at 442, Empire State at 381, and then Woolworth Building at 241. So our answer would be Petronas Tower, Sears Tower, Empire State, and then Woolworth. So Petronas Tower is R, then Sears Tower is S, Empire State is P, and Woolworth Building is Q. So the answer is B, R, S, P, Q. Question number 6. Which of the following is an example of diagrid exterior structure? Aeon Center, USA, Carnegie Hall Tower, USA, Burj Al Arab, Dubai, O14 Building, Dubai. So what is a diagrid structure? As discussed in the previous question also, diagrid structure or a diagonal grid is a framework of diagonally intersecting metal, concrete or wooden beams that is used in the construction of buildings and roofs. It requires less structural steel than a conventional steel frame. The diagrid obviates the need for columns and can be used to make large column-free expanses of roofing. Diagonal members in diagonal structural systems can carry gravity loads as well as lateral forces due to their triangulated configuration in a distributive and uniform manner. Efficiently, they resist lateral shear by axial forces in the diagonal members. Now, the buildings mentioned in the question are Aeon Center, USA, Carnegie Hall Tower, USA, Burj Al Arab, Dubai, and O14 building, Dubai. So, Burj Al Arab, Dubai uses a exterior frame structure with a braced frame structure, and it's evident from the images, which might or might not be given in your questions. So you will have to remember what kind of buildings looks like what. So O14 building Dubai actually has a diagrid structure. It is kind of visible in it, how there is a diagonal grid going on in the building. So the answer is O14 building Dubai. Question number 7. A dash, excuse me. So question number 7, a dash consists of horizontal girdle and vertical column members rigidly connected together in a planar grid form. Coffer slab, moment resisting frame, filler slab, outrigger frame. So what is a coffer slab? A coffer slab is a rib structure with reinforced ribs in the lower zone which have mutually perpendicular arrangement. Ribs between the coffers are reinforced, creating concrete beams and spanning two ways to support the slab. The coffer slab is ideal for longer span slabs carrying heavier loads. So what happens, a coffer slab is also called a waffle slab or a grid slab because the beam is actually in the form of a grid, and in the lower zone of the slab there is a ribbed structure which is mutually perpendicular, which has a mutually perpendicular arrangement. They are called ribs, and these are reinforced and they create concrete beams spanning two ways to support the slab. And the coffer slabs is ideal because it provides large column free spaces and they are able to carry heavier loads. Filler slab. A filler slab is an alternate slab construction technique where part of the concrete in bottom of the slab is replaced by a filler material. The basic principle of a filler slab is that the concrete in bottom half of RCC slab is structurally not required, as concrete acts as compression material which is required in top portion of the slab. So this portion of concrete is replaced by low cost lightweight filler materials like mangrove tiles or clay pots, etc. So what happens in filler slab is that it is a cost effective way of creating slabs, and in the basic principle is that the concrete in the bottom half of the RCC slab is not required structurally, as the concrete acts as a compression member which is only required in the top half portion of the slab. So to reduce the cost of construction, the portion of concrete that is not required in the lower part of the slab, it is replaced by some low cost filler materials like mangrove tiles or clay pots. So this is called a filler slab. Then rigid frames. Rigid frame is moment resisting frame, MRF, consisting of horizontal girder and vertical column members rigidly connected together in a planar grid form. The size of the columns is mainly controlled by the gravity loads, and the size of the girders is controlled by the stiffness of the frame in order to ensure the acceptable lateral sway of the building. Outrigger frame. So outriggers, as discussed in the previous question regarding type A 101, outriggers are structural elements which connect the core of a building to the perimeter columns at one or more levels. Outriggers serve to reduce the overturning moment in the core, and the outriggers are generally in the form of trusses in steel structures or walls in concrete structures. So in steel structures, outriggers are generally in the form of trusses or walls in case of concrete structures. So our answer is moment resisting frame. A moment resisting frame consists of horizontal girder and vertical column members, which is rigidly connected together in a planar grid form. Question number 8. Water Tower Place in Chicago, USA is an example of tube in tube system, bundle tube system, framed tube system, braced tube system. So this is how the Water Tower Place looks like. It is located in Chicago, Illinois, US. The type is a shopping mall or a urban and mixed use development. It was opened in 1976. The architect was Edward D. Dart. There are 104 stores in this building, and there are 74 floors in this building. The total retail area, floor area, is 70,400 meters square. It is named after the nearby Chicago Water Tower, and it is owned by the affiliates of Brookfield Property Partners. So what are the different types of tube and tube systems? So all the four structural systems that have been mentioned in the question are different types of tube systems. I'll quickly explain what are these. So tube and tube system. So a tube and tube structural system is a form created by an inner core within an outer frame tube where portion of the lateral load is resisted by the core. The combined action of the core and the framed tube aids in resisting the gravity and lateral loads. Core and outer tube connected by the floor diaphragm, which transfers the lateral loads to both systems. So what happens in tube and tube system is that there is an outer core, there is an outer frame which is taking the load, and then in the core also there is a structural system which is taking the load. So the core inside the structure also takes some lateral load, and the inner tube and the outer tube both are connected by a floor diaphragm which transfers the lateral loads to both the systems. So this is what tube and tube system is. Bundled tube system. A bundled tube system typically consists of a number of individual tubes. Here when we talk about tube in this system, we mean you can say a tube or a cuboid, or you can say basically a cuboid of structural system is a tube, let's say. So when we talk about of bundle tube, it means that it consists of a number of individual tubes, which means individual squares or cuboids of columns interconnected to form a multi-cell tube. A cluster of individual tubes connected together to act as a single unit. The spacing of the columns may be wider in the tubular walls. That helps to place the interior frame lines to better use interior space of the building. So in bundle tube, there are several tubes, or you can say several cuboids, placed together to form an interconnected multi-cell tube as a structural system. Framed tube. Framed tube is one of the most widely used tube systems. It features a much stiffer exterior tube in this type of system, and the stiff tube is achieved through closely spaced columns connected by deep spandrel beams, which are firmly joined together to make the stiff exterior shell. Then braced tube system. The trussed tube, also termed as braced tube, is similar to the simple tube but with comparatively fewer and farther spaced exterior columns. Steel bracings or concrete shear walls are introduced along the exterior wall to compensate for the fewer columns by tying them together. So what happens in braced tube system is that it's a simple tube system in plan, and it has fewer and farther spaced exterior columns. But in the exterior there are steel bracings connecting the different ends of the system together to compensate for the fewer columns. So the in plan there are fewer columns, but the structural efficiency is supported by the provision of braced in the outer shell. So these are the four types of tube systems, and then this is what water tower place looks like and is. Now looking at the plans and the sections or elevations of the different tube systems. So in framed tube, you see the columns are very closely spaced because there is no internal core. In trussed tube, the columns are scarcely spaced or with spaces, but there is a brace or truss outside the structure to support it structurally. Then in bundle tube, different tubes or different squares or cuboids of columns are built in together. Then framed tube and tube, when the outer is a framed tube, which means columns are placed very close to each other, and there is one internal tube, which means that the internal core is also taking load. Then trussed tube and tube, in which the columns in the exterior are at some spaces, but they are structurally supported by braces, and in interior also there is a core which is takes the load. The core also takes the load structurally. Then framed tube and belt trusses. So in this there it's a bundled tube kind of structure, and which has different belt trusses in it. So our answer is framed tube system. The Water Place Chicago is an example of framed tube system because it has spandrel beams at different levels, stiffening it up, and the structure has columns outside the perimeter. So the answer is framed tube system. Question number 9. Which of the following building structure is an example of bundled tube system? Sears Star USA, John Hancock Center USA, Seagram Building USA, Shanghai Tower China. So which of the building structure is an example of bundled tube system? So this is how the buildings look like. This is Sears Tower in US, then USA John Hancock Center, Seagram Building, and then Shanghai Tower. Now I have added sections and plans of these buildings here. So Sears Star, on different floors you can see it's a bundled tube structure. In the ground, sorry, in the floors, initial floors, it has a grid of 3 by 3 and 9 bundles. Then on the above floors, the bundles are reduced to 7 bundles, 2 are removed. Then on the next floor, 5 bundles are there. Then on the topmost floors, 2 bundles are there. So the bundles are get reduced with few floors each. So Sears Tower is a bundle tube system in which the height of the bundles decreases on some floors. Then John Hancock Center is actually a trussed or braced structure or trussed structure in which the exterior columns are spaced a little, and then they are braced from outside, as you can see in this image also. John Hancock Center, it is braced from the outside. Then Seagram Building is a typical rigid frame structure, and then Shanghai Tower has a aerodynamic shape to tackle the wind, and it has a shape that spirals a little, and it is also I think Shanghai Tower, I'm not sure, but I can see mega columns in the outer structure of Shanghai Tower. I'm not sure what other structural elements are in the Shanghai Tower. So our answer is that the bundle tube system, the example of bundle tube system from the four examples given is Sear Star USA. Question number 10. Match the following structural systems. So three images have been given and three terms have been given. The terms are split core, central core or atrium core. And then you have to match the image with the term. So images are termed 1, 2, 3 and the terms are termed PQR and you have to match them. So there are different core types in high-rise buildings and some of the core types in high-rise buildings are central core. In central core, the core location is inside the perimeter of the building form, surroundings or surrounded on all sides by floor area. So in central core, the core is in the center and it is surrounded by floor area in all sides. Split core. Split core is when two or more cores exist and they will typically have the main core in one part of the building and a secondary binary core elsewhere, perhaps on the other side of the building. So in split core there are two cores where one is a primary core and one might be a secondary core and both can be located on other sides of the buildings also. End core, a core which is located at one end of the building. Then atrium core. So atrium is basically a large open air or skylight covered space surrounded by a building. So in atrium core there is an open space which has a split core inside the atrium area. So there is light coming in the atrium area and the atrium has the core in split form, that is an atrium core. So going back to the images, so 1 is central core. So P is, sorry, we'll have to match the term with the figure. So P is split core. So the P is 3. Then Q is central core. Q is 1. And R is atrium core. R is 2. So the answer is D. P3, Q1, R2. Question number 11. Wind load dash with increases in height of the building. Increases with increase in height of the building. Wind load increases with the increase in height of building. Wind load decreases with increase in height of the building. Wind load depends on climate or wind load remains constant. So wind load basically means the wind pressure or wind force in pounds per square feet or other dimension or other SI units that can be used, which is exerted on a building. Building form, the form of the building or the shape of the building affects the wind by altering its speed and flow patterns and can be used to create desirable wind conditions around the building. Wind in return exerts load on the building, which can be reduced with aerodynamic forms restricted with structural systems. Wind load increases with increase in height of the building. Wind effect primarily causes elastic bending and twisting of the structure, but wind gusts cause fluctuating forces on the structure, which induces large dynamic motions in the structures, including oscillations. So, wind force increases with height and it can cause large dynamic motions, including oscillations, especially on the upper part of the buildings. So, when during the construction of skyscrapers, wind load is a very important requirement that is taken in consideration, and various methods are there, various techniques are there to reduce the wind load on the building, like with the use of dampers to reduce the oscillation and other things. Then, yes, so the answer is that wind load increases with increase in the height of the building. Question number 12. John Hancock Center USA is an example of diagrid structure, raised tube structure, space truss structure, superframe structure. So this is what John Hancock Center looks like, and we have seen this in few of the previous questions also now. It is a 100-story, 128-foot super tall skyscraper located in Chicago, Illinois. And it was officially renamed as North Michigan Avenue in 2018. It was designed by Peruvian American chief designer Bruce Graham and Bangladeshi American structural engineer Fazlur Rahman Khan of Skidmore, Owings and Medal. The building topped out on May 6, 1968. It was the second tallest building in the world after the Empire State Building in New York and the tallest in Chicago. The structural type in is braced tube structure. So it's a tube structure and the outer part has braces on it. So it's a braced tube structure. So our answer is braced tube structure. John Hancock Center, USA is an example of braced tube structure. Question number 13. CTBUH stands for Center for Tall Buildings and Urban Housing, Council for Tall Buildings and Urban Habitat, Center for Transport, Buildings and Urban Housing, Council on Terminal Buildings and Urban Habitat. So CTBUH, the full form is Council on Tall Buildings and Urban Habitat. The Council on Tall Buildings and Urban Habitat, CTBUH, it is an international body in the field of tall buildings, including skyscrapers and sustainable urban design. A non-profit organization based at the Monroe Building in Chicago, Illinois, United States, the CTBUH announces the title of World's Tallest Building and is widely considered to be an authority on the official height of tall buildings. Its stated mission is to study and report on all aspects of the planning, design, and construction of tall buildings. And it was founded at Lehigh University in Bethlehem, Pennsylvania in 1969 by Lynn S. Beadle, where its office remained until October 2003 when it relocated to the Illinois Institute of Technology in US. So the answer is CTBUH stands for Council for Tall Buildings and Urban Habitat, because the council is about the skyscrapers, the tall buildings and sustainable urban design. So the terms used are tall buildings and urban habitat. Last question of today's session. Which of the following is not a type of structural basin? V bracing, P bracing, K bracing or chevron bracing? So what is bracing? A diagonal bracing or bracing is a structural component of just about any building. It provides lateral stability, preventing the collapse of walls, decks, roofs and many other structural elements. And in bracing, basically of structural elements or structural points of the structures are joined together diagonally. So what is K bracing? In K bracing, basically what happens is that the K braces connect to the columns at mid height. So in K braces, the braces are connected to the columns in mid height. So the last image we have here on the down right below is a K brace because it is in the shape of K, because in the middle of the column the braces are connected from the slab. It has more flexibility for the provision of openings in the facade and results in the least bending in floor beams. K bracing is generally discouraged in seismic regions because of the potential for column failure if the compression brace buckles. Then chevron bracing. Chevron braced steel frame, also known as inverted V-brace frame, is concentrically braced frame configuration commonly used in practice. It resists the lateral load with truss action, and IVBF or the inverted V-brace frame or chevron bracing, it provides very high lateral elastic stiffness and strength. V bracing, the diagonal members forming a V shape extend downwards from the top two corners of a horizontal member and meet at the center on the lower horizontal member. So in V shape bracing, what happens is that top two corners of horizontal member meet at the center point of the lower slab member in the shape of V. So just like we had K bracing, that the braces were meeting the column in the center of the column. In V bracing, the braces start from the top of the horizontal member and they come in the middle of the lower horizontal member in the shape of V. And then chevron bracing is opposite of V bracing. It's an inverted V in which the bracing members start from the horizontal members and join on the upper horizontal member in the middle. So our answer is P bracing. So because the question asked was that which of the following is not a type of structural bracing? V bracing, P bracing, K bracing or chevron bracing. So our answer is P bracing. So V bracing, K bracing and chevron bracing, X bracing, all these are different types of bracing. which are mostly based on the shape of the bracing that it looks like. But P-bracing does not exist and it is not a type of bracing in structural building. So that is all for the session, and we were done with the session. I am waiting for others to join the session to ask their questions. That is all. Thank you. This was the last session, and I have explained 14 questions today in this session. I'm waiting for others to join this live session to ask their doubts in case they have any doubts. So this is it for today. For the live session 8, this was the last live session for structure, form and architecture, the synergy. And yeah, I'm just going through the PPT again quickly. So the first question was, in the system where part of the lateral load resisting system is located within the interior of the building is called, and the answer was interior structure. Then second question was, in which you were supposed to match the buildings with the countries. So Seagram building is located in USA, International Commerce Center is located in Hong Kong, and Kingdom Tower is located in Saudi Arabia. So the correct answer was P2, Q1, R3, C. Then typing 101 is an appropriate example of outrigger structure because it has a outrigger truss on some floors of the building. Which of the following high-rise structural system has the highest structural efficiency to build tall structures? And the answer is steel diagrid. Steel diagrid has the highest structural efficiency to build tall structures. Then the question was to arrange the following buildings in descending order, following the tall building in terms of height, and amongst these the tallest was the Petronas Tower, and then Sears Tower, then Empire State Building, then Woolworth Building. Question 6. Which of the following is an example of diagrade structure? And the answer is O14 in Dubai. This is how O14 looks like, and it's a diagrade structure. Then 7th, a dash consists of horizontal girder and vertical column members rigidly connected together in a planar grid form, and the answer is moment resisting frame. So a moment resisting frame consists of horizontal girder and vertical column members rigidly connected together in a planar grid form. Then question number 8, Water Tower Place in Chicago is an example of, it's an example of framed tube system. Then which of the following building structure is an example of bundle tube system? And the answer is Sears Tower. Sears Tower is a bundle tube system. Then you were supposed to match the structural systems with the terms. So P is split core, so third image is split core, Q is central core, and first image is central core, and R is atrium core, which is the second image. So the answer is P3, Q1, R2. And question number 11, wind and load increases with increase in the height of the building. So answer is A, increases. Then question 12, John Hancock Center USA is an example of, it's an example of braced tube structure. And then CTBH stands for Council on Tall Buildings and Urban Habitat. Then 14, which of the following is not a type of structural bracing? So the answer is P bracing. V, K, chevron, X, all these are type of bracing based on the shape of the bracings. P bracing is not any type of bracing. So this was all for the sessions for today. Thank you so much, and I will end the session.